Hello, this is Will Timpson with CAD Craftsman. In this video, we will take our previously basic end connection and make it a little smarter, if not just a little bit more adaptable. Here, you can edit dimensions in the plate, change the plate thickness, and if you change the beam size, the plate moves around. It's that adaptable. Now what we want to do is to take this connection and to modify it so that it determines the beam gauge, puts the holes in the correct location with respect to that, and determines the required number of holes and bolts. We have an extra little sketch here that shows up, which happens when you've changed the size with the new configured weldments. So our first step here is going to be to determine some information that will be needed for the equations. On the right plane, we'll start an assembly sketch, and it's got a couple of lines. And first, this is going to be coincident with the origin. And coincident with the flange of the column. That way, we can determine what the width of that column flange is. This point is going to be coincident with the bottom of the beam. We'll add some driven dimensions to these two to be able to determine the information that we need to know. We're going to take and hide a couple of bolts here. We need one more dimension, and that's a line from the hole center to hole center, and another reference dimension. So these reference dimensions will change the name of the dimension just so we know what they are. The gauge, the beam depth, and the bolt spacing. And this sketch we'll just make as the gauge sketch. Excuse me, dimension sketch. So now we have some information. We can go to Manage Equations and view that information. And now we're going to start with some global variables and create and use some of that. So the first thing we'll do is determine the number of bolts, just N. Now, there we've determined the number of bolts by the AISC standard. And yes, I did cheat, and that equation is saved in a Word document since I use it on a regular basis. So that global variable, N, is going to be used for my number of bolts. Now, the next thing we want to do is determine the gauge for the beam. And we'll just call it gauge. And yes, I cheated with that again. So now we have N, number of bolts, and beam gauge. So now we're going to take these and make use of them. Has to be done very specifically. Double click on the plate to expose the dimensions. You're not going to edit the sketch. So by double clicking on this width, I can hit equals and now take a global variable, and coincidentally that gauge happens to be the same. Good. Now I'll double click on the number of instances and do the global variable in and rebuild. Now, if I change this beam depth, we know that the plate will change. But now when we look at it, and rebuild everything a few times, you see that the number of holes in the plate has changed. And of course, a few of my fasteners have faulted because now they have no more holes. The other thing that you're going to notice is when you hit Manage Equations is these dimensions have faulted. And that's a consequence of how SolidWorks operates. You cannot actually tie a global variable to an underlying part. Global variables can only be tied to the assembly level. So there's a simple fix for that. We're going to come back here to the file properties, and I'm going to make myself a couple of file properties. As convention, I'm using a lowercase m in front of them, and I'm just going to make it equal to the global variable. I'm going to do the same thing with the gauge and say OK, and go back and fix our little problem. So toggle it, hit the equal sign again, and now use a file property and swap it, and do the same thing for the number of instances. And when it goes to the file property, now when we go to Manage Equations, we've lost our automatic solve order, and we still have a little bit of mustard color. If you turn automatic solve order back on, it's fine. What this is you need to go to the ordered view, take anything that is tied to a file property, and drag it to the top of the tree. And that'll clear everything. And you can turn automatic solve order back on. So we've tied our plate to the beam depth. We've tied our gauge to the column. So if I edit this feature, and let's make it something a little smaller, I have a narrower flange. Now when I rebuild this a few times, my gauge has changed to something that's more appropriate. So we're going to take these fasteners and I'm going to unsuppress fastener 1, and I'm going to delete the other instances. So fastener 1 lost its mind because its hole disappeared. So we'll put it back in the top hole. Now, we'll take this and copy it. We do want it to be the same coincidence. And we'll locate it on the other face. So all I have is 2 fasteners in the top 2 holes. We'll take those now. Of course, this one needs to become an envelope again. So we'll take these and create a fastener pattern. Just a linear pattern along the plate. Add a little bit to this. Choose bolts to pattern. And we don't care exactly what things are right now. Say OK. And just for completeness sake, that now becomes the fastener pattern. So when we click on the fastener pattern, we get the same thing. I can take this spacing, but here I have nothing to attach it to. I can attach in to the global variables. And since this is the assembly level, it's fine to attach it to the global variable. We'll come back to the equation and add a global variable that's the bolt spacing and just make it equal to this dimension. And if I want to, I can come down here into the equation, hit the equals, global variable, bolt spacing, select it right there in the equations view. And you can change everything in the equations view. And one thing to point out is SOLIDWORKS claims that you can use all Excel functions in these equations. However, a nested if statement must actually be an if and only if statement. You cannot put one inside another with a simple if statement. That's why you'll see these are all IIFs, which is if and only if. So now we say OK. And our fastener pattern has turned itself back to where we want it to be. Our holes has now faulted because it's lost its mind in the sketch. So we're going to edit this sketch and we're going to delete this bottom 4 holes. Create a linear sketch pattern. Again, in the Y direction, we'll add a few. We'll make it some odd number and change its direction and use these pieces. Make sure you dimension the Y spacing, display the instance count. Say OK. Now I've made my holes. But I want to take this sketch and now attach it to a file property. And I forgot to do the file property for the bolt spacing. So we'll create a bolt spacing file property and just attach it to the bolt spacing global variable. Run that circle right around. The instance number is the file property in, and the spacing is the file property bolt spacing. Now, rebuild it, and everything is hunky-dory. So now we have our holes, bolts, and plate all attached to equations which drive them. Let's test and see if we've done our job. When I changed the size, I obviously faulted that cut, but we'll take it and copy the connection over. Select any component, select the point of insertion, the welded member, and the bolted one member, select OK, and it should resize itself and make the new copy. And now we have a 3-bolt connection and an appropriately sized plate. And to test this, I'll modify this section and we'll turn it into something quite a bit larger. And Steel Designer Pro will go through and check the dummies on each end, process the equations, when it changes the beam size. And there's quite a bit going on in calculations to make sure that everything moves. So there are all the holes in that column.